afternoon, everyone. First of all, thank you so much for inviting me for this special topic on high performance concrete. So, to begin with, I'm going to present you that today's topic is regulatory considerations for high performance concrete, ensuring compliances and innovation in construction. So, to begin with, let's understand the basic like what is high performance concrete. Of course, it's a specialized type of concrete known for its superior strength, durability, and low permeability compared to the conventional concrete. High performance concrete is increasingly used in the critical infrastructure and complex projects. It becomes essential now to understand its unique properties and importance for aligning its use with the regular standards. And of course, the key benefit of using the HPC is its enhanced durability, which leads to long-lasting structures with reduction in maintenance need compared to the conventional concrete. Now let's understand the importance of regulatory compliances. Why we need a regulatory compliances? Firstly, of course, for the safety and reliability, as compliance always help us to mitigate the risk by using associated special advanced material for which the structure is intended to use. Next is alignment with the standards. Many times the HPC meets the industry standards and best practices for which the regulatory always plays an important role, which supports its effective and safe application, facilitating innovation. Regulatory compliances or regulatory guidelines, always frameworks, allow for the integration of new technologies and materials, like of course what the high performance concrete is there, while maintaining its safety and performance benchmark as well, which is very, very important. And minimizing risk, like proper compliance always reduce the potential legal and financial risk by adhering to its codes and standards. So this is why the regulatory compliance are needed for the HPC. Current standard governing high performance concrete, like overview of relevant standard, we have all know that establishing standards such as IS 456, IS 10262, and ASTM standards that apply to the high strength and performance concrete. But however, the limitation of existing standard, like examination of like how existing standard many times may not fully address to the unique and special properties for the tailor-made concrete or for projects, what we can say, such as let's say high strength and enhanced durability, many times which necessitates supplementary guidelines as well. So the key regulatory bodies for HPC, like firstly, as we all know that ASTM International, which always gives more into the materials and testing methods. Then American Concrete Institute ACI codes, such as let's say ACI 318, which gives a detailed concrete design and construction for structural concrete, ensuring its safety and performance. Then ISO, International Organization for Standardization, always established a global standards that cover a wide range of material and practices. And then local building codes specifies regulations and requirements vary by region to region. Let's say for projects, for special projects, considering the safety and environmental and performance standards. Then moving towards next, standards and specifications. If you consider about the ASTM C150, which standard specifies the requirements of Portland cement, which is a critical component of the HPC. It's the properties and testing method and quality control measures as well. ASTM C595, which mainly focus on the blended hydraulic cement, which are often used in HPC formulations. These standards define the requirements for the various type of blended cement, including with the SCM like supplementary cementitious materials to ensure the proper performance and durability. ACI 318 will give the guidelines of design and construction of structural concrete. ISO 22965, as discussed, offer the global standard for the concrete, including its performance requirements and testing methods. It also addresses the quality and durability of concrete, promoting consistency and reliability of HPC applications worldwide. Quality control and testing. So basically, four different quality control and testing we have divided. Like first, say the compressive test, compressive strength testing. Of course, it's a ability of the concrete to withstand the axial load without its failure. So it involves the rigorous testing of the concrete samples at various curing edge to achieve the required strength, which is crucial for the structural integrity as well. Then durability testing, it's a concrete resistance to environmental factors such as freeze-thaw cycles, chemical attack, alternate wetting and drying throughout its service life, like abrasion. So this ensures that the high-performance concrete can endure the harsh conditions over its service life, throughout its service life, and which will minimize the maintenance and repairs needs over the time. Then workability testing, that evaluates the ease of with which the concrete can be mixed, like let's say in RMC plant or site, then transportation, then placing, and then finished. So the workability, such tests like slump test or flow table test ensure that the HPC mix has been appropriate consistency and can be handled efficiently during the construction. Shrinkage and creep testing, it measures how the concrete dimension are always changes over the time under the sustainable loads. Now moving towards the environmental and safety regulations. Environmental impact is, which I consider this is one of the most important issue to be discussed. Like all the regulations shall be aimed to reducing the carbon footprint and promoting the sustainability. This includes like managing emissions, conserving resources, and using the eco-friendly materials. Compliances like LEED can also be focused, promoting sustainable building practices. Safety standards after environmental, let's ensure the worker safety during mixing, transportation, handling, and application is also critical. Safety regulations cover the protective, like use of PPE equipments, compliance with the OSHA guidelines helps to prevent the accidents and health hazard on the construction sites. Waste management, of course, solid waste management is the key problem in coming day-to-day life, and which is increasing day by day, I believe. So like recycling the leftover materials, managing the byproducts like waste products, and plan a thing such that it will minimize the waste generation. Like, what are the key regulatory consideration for the high performance concrete? First, understand the material specifications and mix design. Like regulations regarding the composition and the quality of high performance concrete, including the use of additional supplementary cementitious material as per the performance based criteria, ensuring the mix design meets the required strength, durability, workability standards. Testing and quality assurance as a key regulatory consideration, what we have mentioned here. Like, of course, any standards for testing HPC to confirm its performance characteristics such as durability, workability, strength parameters. Emphasis on advanced testing materials, or what we can say rigorous testing, and the quality control measures to ensure that the HPC meets the regulatory requirements throughout its life cycle. Of course, this is not so that easy, because in normal conventional concrete, we have so many challenges. So like high performance concrete is something more than this. Durability and environmental resistance, the guidelines for assessing the HPC's resistance to the environmental factors such as chloride ion penetration, freezing thaw cycle, alternate wetting and drying, chemical attack. Like compliance with the regulations will always focus on the sustainability and environmental impact. What are the challenges in regulatory alignment? Basic challenges like compatibility with the existing standard. Many times it is difficult how traditional standards may not fully accommodate many times the full characteristics of the HPCs because they have the high strength with the low permeability. So the need of updated guidelines to address these differences and ensure HPC is used effectively and safely throughout its period for what we have designed for. Construction process control, that challenges for maintaining consistent quality and compliances during the mixing, placing, and curing process. Many times the construction crew is not aware about using this specialized material. So the ensuring that the construction practices meet both requirement and regulatory expectations. Life cycle and low-term performance. HPC's long-term behavior due to its advanced properties. Like, it is always difficult in standardizing or what we can predicting its long-term behavior. Although we are now started using it, but its structures behavior in a decade or more. This includes ensuring that the regulatory frameworks adequately address that the material's durability and performance over time. Now let's understand the emerging standards and guidelines. Of course, new strength and durability standards, anticipation of updated guidelines, which will set up the specific performance-based criteria for the HPC, including where the strength is on the threshold and the durability benchmark that will address its unique properties. So let's assume that there will be a recurring cost will be very less. Enhanced quality control and testing procedures. The development of the advanced testing protocol, which is the need of an hour for the HPC, and the quality control measures, which will be tailor-made, ensuring that accurate assessment of its performance and compliance with the regulatory requirements. Sustainability focused guidelines, that what we have discussed earlier, that the carbon reduction in carbon footprint, because the major and basic component is the cement, which is adding the carbon footprint, so that we need to use more SCMs and eco-friendly material and assessing the overall environmental benefits of the HPC. Impact on the industry, like how these evolving standards will facilitate the adoption of high performance concrete while ensuring the safety, performance, and sustainability. Of course, the role of all industry stakeholders, not only industry stakeholders, but the researchers, academicians, like bureaucrats, politicians, all the stakeholders can come together in shaping and adopting to these new guidelines, which is the need of an hour, I believe. Best practices for ensuring the compliances for which we are standing, like early engagements of the regulatory bodies, like importance of initiating and discussion with all the regulatory bodies, agencies early at the beginning start of the project itself, and address any potential compliances issue if any, so that during the work there won't be any issue. Comprehensive documentation and reporting, like maintaining detailed records of mix design, testing results, and quality control procedures. It is documentation and reporting is, I believe, of course, one of the key factor. Like, many times I've seen that after the construction, unfortunately, the mix design records and the testing results, generally they won't keep on site or office records. Continuous monitoring and quality assurance. Continuous monitoring is become the key role now. You might be aware all that the structural health monitoring also come into picture now. Just to understand the behavior of the concrete throughout its service life and under the sustainable load. So implementing the rigorous quality control and monitoring process throughout the mixing, placement, and curing stages. When we talk about specifically about the HPC, so in all three stages, like mixing, placement, and all the curing stages, continuous monitoring and quality assurance, staying updated with the evolving standards, like keeping abreast of changes and updates in HPC standards and guidelines to ensure ongoing compliances and adapt the new regulations as they emerge. Coming back to the conclusion of the presentation is regulatory compliances organizations like ASTM, SCI, and as you know, that HPC meets performance, safety, and durability requirements, which contributing for the overall success of the project. Quality control, rigorous testing, more number of testing, rigorous testing, number of tests, not only for the workability but the durability as well. Raw control and the basic quality control practices are critical to verify the HPC. Environmental and safety considerations like complying with all the environmental regulations and safety standards and ensures that well-being of workers. Because as we discussed that many times, the construction crew is not aware about this HPC. So special training programs and education, how to handle, how to mix, how to place is also important. Documentation and certification, as recently we discussed, like proper documentation and certification practices are crucial for tracking the compliances, facilitating inspections, and maintaining transparency throughout the project and after the project as well. So let's say, if the something is happen, if any collapse or accidents will be there, and when the forensic engineering to be done, so such documentation and certification play the important role while arriving a conclusion for the particular incident. Future trends, staying informed about the advancements in HPC technologies, regulatory changes, and sustainability practices will help stakeholders to adapt to evolving industry demand. Future, it might be, in future that the self-healing concrete or bacterial concrete may come up or incorporate with the high performance concrete. And let's say we have something, different to solve the specific problem. Let's say not for the new construction, but for the existing retrofitting and repair projects as well. So this is all about the basics of high performance concrete and its regulatory compliances or consideration. Thank you so much.
Thank you, sir, for an insightful presentation on regulatory consideration.